So yesterday I was collecting data from you guys, and on that data, well, this was my sample sheet, and then down at the bottom, I was collecting your R values. Okay, so as people were coming up to me, I got what kind of ruler they had. So did you have a 0 to 30 ruler here, where you just had one marking? Did you have three markings where you had 0, 10, 20, 30 marked? Did you have it in increments of one where you had 1, 2, 3, 4? Or did you use one of the rulers that allowed you to get down to the millimeter? Okay. If you look at our R values here, our R values, this is a little skewed for this one. No, it wasn't this one. Yeah, we ended up a little bit better with this one than this one, which I find a little surprising. My guess is that person, whoever did that data point right there, probably wasn't the best data point. So if we pulled that out, you would see that this ruler here was the better ruler. Okay, and we can look at that and see that trend from the R values. Mr. Schramm did like a graph here showing that as a general rule, you increased with your precision as we went across there. Okay, and that's what we were hoping to see. The more markings you have, the more precise your work becomes. Now, how do we factor that into our data? Well, we are going to go on a quest the next few days, dealing with something called significant figures. Okay, so I'm going to start you today with significant figures and kind of like how to count how many significant figures you have. And then on Monday, I'm going to show you how to do math with it. Just multiplication, division, subtraction, addition. Okay, so we need to talk about different parts of the number. Zeros in the front of a number. You can see what those would look like here. Non-zero digits. You're going to be able to identify things that aren't a zero. Yes. Zeros that are between non-zero numbers. So I call those kind of captured. Whoops. Hello. What happened there? They're kind of captured and held into place. And then zeros at the end of a number. See what those things are? All right. So let's look at some rules. So make sure you're paying attention to this and not your lab right now. You'll have some work time in class today. I want to make sure that you have enough time or that you understand this material, okay? Because this is really like we do this all year long and it's a little bit confusing if you don't get it. You know, make sure that you're coming and talking to me. So pay attention to this. You should be in your note packet at this point. All non-zero numbers are significant. Sandwiched zeros. So those are zeros that are between non-zero numbers. They're captured in between there. They are always significant. Leading zeros or zeros at the beginning of a number are never significant. There is no case that is ever going to happen. Zeros at the end of a number or trailing zeros are only significant if there is a decimal in that number. Counting numbers and conversion factors and values off of the periodic table are always considered significant. So we're only looking at numbers that we are measuring in a lab situation or somebody has measured in a lab situation. Good? All right. So how many significant figures are in this number based on the rules that I just shared with you? Is 3 significant? Yep, so that's significant. Is 5 significant? Why is 3 and 5? Why are they significant? They are non-zero numbers. Are these 2 zeros at the end of the number significant?
Yeah.
Why? There's a decimal. So zeros at the end of a number that contains a decimal are significant. So this has how many significant figures? 4. We oftentimes, instead of saying significant figures, we say sig figs. So you'll hear me talk about sig figs. If you get sig figs wrong on a paper, I write SF next to it because I don't want to write out sig figs 500 times when I'm grading a group of papers. I'm that lazy. Okay. So that is one of the abbreviations that I use all year long. You're not going to change. Okay. So I want you to work with the person next to you. This is a counting number. Okay. But I want you to work with the person next to you. So I don't know. Sophie, if you want to move up, and then you can have a partner. So work with the person next to you. Underline the ones that are significant, and then off to the side, write how many significant figures there are. Okay? See if you can use that list to identify those. Is this quiet enough for you, Grace? Are you okay?
Yeah. What does it say? What does it say about two. But that's zeros are so 4, 2, 6.
Read the rules. Talk to the person next to you. Underline the things that are significant.
Yeah.
Oh, right, you have the 4 digits.
Sophie, do you want to move up, or do you want to talk to them? Do you compare answers? Are you guys done? Did you talk to each other about your answers? Take their share.
Okay,
Oh, tell about that one.
Oh, wait,
There would be a decimal.
why am I forgetting all
So
the
scientific notation, there would be a decimal. But you actually have to put decimal in. Trailing zeros would be. So I can see
All right. Does any group need a little more time? Or are you ready to talk about it? Okay.
this without calculator.
I six double checked. Yeah.
So we've got
You can have to do this.
here and here are non-zero numbers, so those are significant. Is this zero significant?
Yeah.
Because it's captured, it's sandwiched. So we have 3 sig figs here. These, how many here? 2. That's an easy one because they're both non-zero numbers. Here we have a 9 and a 3. This 0 is sandwiched. What about this guy? No, he's not significant. There's no decimal in this number. If we wanted to make him significant, what would we have to do? We'd have to put a decimal. So if I put a decimal here, then that would make that 0 significant. But there's not a decimal there, so this is only 3 sig figs. That make sense? If I wrote down 9030 dot, then I would have 4 sig figs. If I wrote now 9030 decimal 0, now I have, how many sig figs would I have now? 5, because I've got non-zero number, sandwiched, ending zeros where there's a decimal. So then I would have 5 sig figs. And when I add another 0, I would have 6, and I can keep going. That decimal is going to make every one of those that comes at the end significant. All right, how about this? 2 and 1 we know are significant because they're not zeros. Are these zeros at the front significant?
No.
Never. What about these 2?
Yeah.
Yep, they're sandwiched. So I have how many sig figs here? 4. Okay, 9 and 8. Are these zeros at the beginning significant? What about this guy here?
Yes.
Yes. So I have how many? 3. Now this is counting numbers. We're counting cars. 1, 2, 3. So how many sig figs here?
2.
2. Or infinite, if you want to think of it that way. It's a counting. Okay. So 1, 2, 3, 4. All of those are significant. It's a counting unit. We didn't use any kind of instrumentation to get that value. Yep. How about here? This is a little tricky. Yep.
If you convert it into standard notation, would it be 2?
Yes. Yep. So this is 2. When you are looking at something in scientific notation, you always just look at this part of that number. This part right here is what's going to determine what digits are significant. And that's an excellent way to do it, is to turn it into scientific, or take it out and put it into standard form. So that would look like this. 1, 2, 4, 5. Those don't have a decimal at the end. They're not significant. If we had something like 2.5 times 10 to the minus 3, how many sig figs there?
Still 2?
Still 2. Remember, we're only looking at that part of the number. If I put this into standard notation, that's what it would look like. And remember, zeros at the beginning of a number are never significant. Now, you still need to use them in your calculations. They're not just going to go away, right? They're not just going to go into the background. You still have to punch them into your calculator, but they don't count as being significant. Now, why does this matter? You'll see on Monday. Okay? I don't want to try to throw too much at you at one time. I want you to get comfortable being able to identify how many sig figs exist and a specific number before I throw some math at you on Monday. Now, the math is just adding, subtracting, multiplying, dividing. It's nothing complicated. Okay. I mean, literally adding like 2.0 plus 5.00. Okay. That's the kind of math we're talking about on Monday. That's the kind of math that's going to be on your quiz. Like I literally put numbers like that you should be able to just do in your head on your quiz next week. Okay. Yes, you have a quiz next week. Another one. Okay. So comfortable doing these? Okay. So that's going to lead into our discussion on Monday. So you have some time to be able to spend doing your homework, which I see some of you have already gotten done. Make sure you double check those answers online. Okay. If there's something that you see on there and you're like, I don't think that's right, come and talk to me because one of us is wrong and it could be my answer key. And then you've got time to work on your lab. If you want me to look over your lab for you, anything like that, let me know. Why is this not letting me? Oh, that's why. I run into that every time.